All right, line V1, we're into learning task 5, which is going to be our across the line starting circuits. So we described the starters in the previous video where we took a look and we said, hey, we've got this thing called the contactor, we've got this other thing called the overload block, and we're going to mash those two together, and at that point we've got this thing that is going to be called the starter, which involves the starting component, the contactor, and the protection component, which is going to be the overload. What we're going to do now is we're going to go and take a look at how those components actually get applied into a circuit. In other words, we will connect the motors themselves to it. Over here, we have got a power circuit. Now, it's a power circuit for a three-phase motor. How exactly three-phase works isn't something that we need to concern ourselves with yet at this point. You will cover lots of that inside of your third year. Ultimately, a three-phase motor is going to be able to be defined by just three connections going into that motor. So we are going to go and deal with all of that as one section over there. We are going to have, we are going to go and have another section over here, which is going to go and be referred to as my starter section over there. This is all components that are going to be inside of my starter, right? We see we've got the actual motor contacts. This is where we would lead in on L1. We would then go through, there's that internal junction. We then go through the overload heater or current sensor, and then we come out on this terminal over here, which is going to be my T1 that we are going to have. All of that is contained inside of the starter. Upstream of the starter, we are usually going to go and have a fusible disconnect switch. It might not always have fuses in it, depends upon what it is. Some places there's just a disconnect if it's sized correctly, but we are going to have something upstream that is going to go and provide overcurrent, OC, protection that we are going to have over here, as well as provide for isolation. Okay, everything inside of here does different purposes. Although it looks like, we've got a couple of things that go and watch current, we do, these two, they're both watching current for separate things. The fuses are watching for overcurrents, dead shorts, anything that's going to be more than 6 times the regular rated current. The overloads are watching for small increases in current. Each of them responds differently. The overcurrent would never go and catch an overload. The overloads would never be able to clear if there was a massive, short on the circuit. So they each have their own purposes. Same with these over here. If I take a look, this is going to be a disconnecting point. This is going to be a disconnecting point. But this is going to be used as isolation, so I can flip that switch, lock it out, and work on everything safely downstream. Whereas this one is being used as the actual start-stop. That is going to go and provide power to the motor itself. We don't start and stop motors off of these switches. They're just not rated for that horsepower, and the speed at which we move our little, human hands back and forth is just way too slow. There'd be way too much sustained arcing and stuff across them. These are going to be referred to as power circuits, what we have drawn over here. Now, we aren't going to draw the power circuit out for every single bit of motor control that we are going to do. It is just an understood part of our trade that you understand every single time that there is going to be motor control circuits, all of these things that we're going to look at later on, that these are always referring back to my contactor, my starter, and my overloads that I'm going to have over here, placed in conjunction with an overcurrent device and an isolation device. So we won't draw these every single time. We will just take a look at it on this one. Everything else inside of here, we're just going to say it's referring to that. There's one really important section inside of here that we haven't talked about yet, and that's going to go and be this. These two lines over here, which are going to be taps that are going to come off of my contactor and go over to my control circuit. The control circuit is going to go and have the push buttons, the start stops, and the things like that that will be inside of it. Okay, I do want to note as well where the control circuit comes off. The control circuit is coming off downstream of the disconnect, so that if I have thrown the disconnect over here, I'm going to also be isolated on the control circuit. Generally speaking, if I'm going to go and work on a motor, I'm going to go and throw the disconnect switch, then I'm going to go and pop these fuses out and put them into my pouch so that I don't have anybody else that's going to go and be able to start that thing up until I'm fully ready to go and do so. Okay, let's talk about 2-wire versus 3-wire control now. 2-wire control is going to be a type of control that has actually, just 2 wires to a starting or stopping device. So whatever starts and stops the circuit has only got 2 terminals onto it. A great example of something that has got 2-wire control is a switch, right? A standard toggle switch that we could go and use, those motor-rated types of toggle switches, are just going to have 2 terminals, line 1, T1. Whenever I would close this over here, now this switch itself might be rated only to be able to carry, let's say, 12 amps over here. What I can do with this 12 amp switch is that I can place this thing in line with my contactor coil, this section over here, which I'm then going to put in line with my overload contacts. Note, these aren't the overloads, these are this set of little tiny contacts that are going to be associated with the overloads on my power circuit. Going back to this one over here, the interaction between my power circuit and the control circuit is this. The power circuit is going to go and have all of these M contacts that are going to be controlled by what we refer to as the coil. The overloads over here are going to go and have each of these individual, normally closed ones, that we are going to go and use to control the coil itself. So if I were to go and look at these things and say, well, what's feeding into the circuit, what's feeding out, it's as if my heater overloads are providing a output to my control circuit, and then my control circuit is providing the actual input back into my power contacts. Going back into this one, that's what we've done over here. That motor could have been, a 100 horsepower motor. That's fine. I can control it with a 12 amp switch because that 12 amp switch is never actually switching the motor current. It is just providing a pathway through to the coil. When that coil energizes, it will go and close all three of these, tick, 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 which would then go and provide power through to the motor. We'll just draw that over top of here. Just erase a bunch of this actually first so that it's a little less janky looking here. So it's going to go and provide power to the actual motor. When I've got current going through to that motor, my overloads are going to be monitoring that. If these overloads sense too much current being taken through the motor, that the motor is going to start to get too hot because of the amount of horsepower that are the amount of amps that we're taking from it, those are going to go and activate those little normally closed contacts, which would then go and open up this circuit over here. So these that are normally closed would now go and open. When that opens up, that will interrupt current flow inside of this control circuit, which would go and shut down those ones right over there. Let's erase that like that. Shut down those ones over there, and that's what's going to go and shut my motor itself back down. That's my interaction between the two sides of the circuit. The power circuit, which is applying power to the motor itself, the control circuit, which is controlling that power circuit. If I were to trip out and go on overload like this, what would then need to happen is I would need to reset that overload. Now, if I were to go up and just press the reset, what would happen? Well, you should note that this switch is still closed and that instantaneously this motor would be released to start up again. It's going to go and automatically restart. Two-wire control provides what we refer to as low voltage release. Okay? Low voltage release just means that after a power failure or after a reset on the overloads, then my motor is going to be released to begin doing its thing once again. It is an easy thing to remember if you just break it up into the syllables. Okay, this word over here has got two syllables, release. Okay, you can try it, release. It's got two of them, therefore this is going to be a two-wire word that we're going to use. There is going to be another type of low voltage protection that we are going to have, and that's going to be low voltage protection, which is going to be associated with the three-wire control circuits that we're going to look at here in a second. But yeah, just work off of the actual syllables off of those. All right, I'm going to erase these over here, and then we will move on to the next one. Okay, three-wire control circuit. The three-wire control circuit refers to the fact that if I were to look at the thing that is starting and stopping the motor, that's these over here. Together they work in conjunction to start and stop the motor. I would see that there are three wires that come out of this box over here. We would use that if we were actually trying to go and figure out the number of conductors in conduit. I'll show you how to do that later on. It's the easy way to figure those things out. But we refer to this as a three-wire control type of circuit. We get really, really used to seeing these. These are going to become my base type of circuit that I'm going to build most of my controls off of. And they're this fun circuit that has a form of feedback inside of it. Let's go through and trace power into the circuit right now as it is at rest. At rest, we're going to go and have current that will be able to be carried or I shouldn't say current yet because we don't have current till we get through. Let's start with the value of voltage. Right now I'm going to have voltage that is going to be able to pass through up to there and pass through up to there. But that's as far down that circuit as my line 1 is going to be able to travel, because it's going to be blocked by that normally open start, as well as it's going to be dropped by what's over here at the bottom, which is referred to as our sealing contact, or sometimes we're going to go and hear them auxiliary contacts or maintaining contacts as other words. Sealing is a pretty standard word, though. We'll use that one for the bulk of what we're going to be looking at. So we stop all of our power flow right over there at the sealing contact. Let's examine what happens when we actually press the start button. When we press the start button over here, it's going to make contact across that point. And at that point, we're going to be able to have voltage that we can then apply all the way through here up to that side of my coil. It's a 240 volt coil. I see that on the other side, I've got my line 2 that is applied through the normally closed contacts over there, which would mean at this point, I am going to go and have activation of that coil, right? We see that this is a 240 volt device. It's got line 1 and line 2 both brought to it simultaneously. So therefore, this thing is going to go and energize. When it does energize, it is going to go and close all of its contacts. So it's going to go and close all of these over here. And at the same time as it's closing all of those, it is also going to go and close this over here. It's sealing contact or auxiliary contact. In the previous video, you should have remembered that we had those drawings of those contactors that were brought up over there. We had that 1314, which was going to be my auxiliary normally open contact. We have now closed that in because this coil itself has provided a form of feedback into this circuit. Well, if that coil does that, that would mean that we would be able to split our current. Our current would travel some through there, some through there. At that point, I can take my finger off this push button, open that one up again, but if I look at this, I see that I have still got a path for current that is able to go and travel all the way down through my line 1, through my sealing contact, and back to that side over there. I no longer need to hold that push button in. This is referred to as a sealing contact over here. We refer to this as 3-wire control once again. My motor is going to continue running now until I remove power, because once I remove power, I'm going to remove that feedback and the whole thing is going to shut down. Let's go with a regular shutdown. A regular shutdown would be me interrupting the current over here at the stop button. If I were to take that stop button and I were to open it up, just like that, that'll interrupt current over there. When it interrupts current over there, that is going to go and interrupt the current that is traveling all the way through to this coil. This coil would then shut off, which would mean that this contact would go and reopen. And then I can take my finger back off of this one and reclose it, and we would be back to where we began with. Right? Voltage being brought up to those 2 points. We've gone and effectively shut this thing down. If I go and press start again, so I press start, I carry the voltage through to this side, this whole thing energizes up over there, and my sealing contact seals in. Take my finger back off of that one again, and now I've got power that is through up to that coil, so my motor would be back running again. If I were to go and get too much load taken by my motor, once again, so the motor starts to bog down, my overloads are going to start to generate heat, and as they generate heat, they're going to eventually cause my overload relays over here to go and open up. So these ones, one of these is going to go and open up. Whichever one it is, doesn't matter because it's a series circuit. So one opens up. When that happens, we remove current from that side, and I'm going to go and see my contactor, which would then go and open, or my contactor, which would depower, which would then open this contact. I guess I forgot to draw that one in there a second ago, but it's going to go and shut down that motor. So we would be able to go and pull all of this off, and that would be fine. If I go to this one, and I reset my overloads, note that my motor does not come back on. It still requires me to go and press that start button. Remember how this one, if I had a complete path for current flow, we'll just draw the same colors over here, all the way up to there and up to there. This is my 2-wire control, which provides release over here. If I were to go and lose one of my overloads, like that, take this out over here, and I would take out my coil over here, the motor would shut down, but the second that I go and reclose this again, I see that I'm instantly going to go and have power back to that coil, right? It would go and be released to begin operating again. Compare that with this one over here. We saw that when we lost that, we shut the coil off, but then we lost our sealing contact. We can reset the overloads, but once we've got the overloads reset, we still have to wait then for this to get recontacted again. So we've reset our overload. We will go through this one more time over here. Voltage up to there. We will press our start button, boom, like that. When we press that start button, it is going to go and provide current through up to there. We then energize this. When that energizes, it closes our sealant contact. We now have a path that looks like that, and then we can take our finger off of that push button. Once we've done that, we're now going to be operational. The last thing that we're going to use to shut this down is a complete and total power failure. Okay, so we'll just do that. Okay, power failure on the installation, boom, everything loses power. When it loses power, once again, these contacts over here are going to fall back open, which means that when power comes back on again, we are only going to go and have power up to these 2 points. Once again, we need to wait for somebody to press that start button. These types of three-wire circuits provide what we refer to as low voltage protection. Once again, count the syllables. 3-wire, 3 syllables. Protection compared to my 2-wire release that I'm going to go and have over here. Okay, this section, this first little bit that we've gone through, going through this 3-wire control circuit is so critical. Almost everything is built off of it. If you don't get what's going on, just do that whole rewind thing and watch through it a couple more times until you understand the interaction between this coil and the sealant contacts and how it is sealing itself in over there. Don't move on into anything else until you're ready to go and do that, because everything else is going to go and use this as a foundation to build from. In fact, so foundational that we're actually going to go stop this video here right now, and then we are going to go and do all the extra add-ons in the next video.